So guys, I don't usually do videos like this where I'm just basically talking math like a geek, but I'm going to try to make this mostly entertaining for all of you, whether or not you like math or you just couldn't care less. Basically, the reason I made this video was because I had this amazing theory about the number infinity. Now, if you guys don't know, infinity is a really uncertain number in math that looks something like this. I'm sure you've seen it somewhere across your life. And basically, it's just such an uncertain number because infinity actually has no set defined value. We can think of infinity as not defined. But it's time we change that, right? It's time we try to give a definition to infinity because, hey, infinity deserves a place in the number system as well. So if we think of a couple of things that we can do with infinity, we come to the conclusion that some infinities might actually be greater than other infinities. Basically saying that infinity 1 is greater than infinity 2. This is not really hard to think of because we can think of like some infinities as 9 going infinity times, and then we can think of some as 9 8 going infinity times. Clearly, this infinity is going to be greater than this infinity, but they both are infinity, huh? So how does that exactly work, right? That's not really logical or anything. Well, if we come to basically the system of numbers, if we come to the graph of complex numbers, we have the imaginary numbers as the y-axis, and we have the real numbers as the x-axis. The origin is, of course, 0. If we look at 0, 0 has a very set, defined value, right? 0 is fixed value. 0 is like in its place inside the plane, and 0 knows exactly where it has to be. But that's not the case for infinity. Currently, where infinity lies is at the end of the real axis, over here as infinity, and over here as minus infinity, because you have 1, 2, minus 1, minus 2, And in the imaginary plane, of course, you have I, 2i, minus 2i, and so on and so forth. But if you notice, there's actually no end to this 2i in a minus I infinity. This number does not actually exist on the plane. So why should these infinities exist? You know, this is such an uncertain place. Sort of like hydrogen in our periodic table. Like, this is just a very uncertain spot to be for infinity. So if the real numbers can have a plane sort of like this, and if the imaginary numbers can have a plane, why can't infinity numbers have a plane? And if we look at the complex number plane as a whole, we do have the y-axis and the x-axis, but the z-axis is actually missing. So there's actually place for a third sort of a plane. And that is basically my theory on infinity. You may call me mad, okay, before you click off and fit of rage, just hear me out, okay? Basically what I'm saying is that our third axis over here, the z-axis, is our infinity axis. Basically represented by whatever. You can name it better, I know, but I just basically want to present my theory, right? Possible axis, real axis. And basically what this infinity axis will have is it will have the numbers from like infinity to infinity, minus 2 infinity, and so on and so forth. The rest of the plane, like the rest of the axes, will remain exactly the same. But you see where I'm going with this? Like if we look at the real plane a bit closely, if we look at the real axis a bit closely, you have 1, 2, 3, 4, and so on until, like, you know, never ending. We're not going to call it infinity anymore. Never ending till 9999999, because the number 999 is actually not infinity. Infinity is a much more sort of a uncertain number that cannot be put into nines as easily as that. So basically how these can be expressed is 1, 2 into 1, 3 into 1, and 4 into 1. Basically where the factor is all 1. They all increase by a factor of 1. Similarly, in our imaginary axis, we have I, 2i, 3i, and so on. Basically, this can be written as I, 2 into I, 3 into I, where the scale factor is I. So in the same fashion, if we take our infinity axis, we can write it as infinity, 2 infinity, 3 infinity, where these can be expressed as 2 into infinity and 3 into infinity, the scale factor being infinity. So if you look at this a bit more closely, suddenly everything fits into place. You know, all of the missing paradoxes, all of the missing lines, all of, all the stuff that we were missing, it all suddenly snaps into place. To sort of, prove this a bit further, I would like to take the equations 1 by infinity equal to 0 and 1 by 0 is equal to infinity. This is very easy provable. If you disagree with this, either of the equations, just let me know in the comments. I'll make another video explaining why this is true. But both of the equations are true, widely used in physics, maths, all across everywhere, okay? So basically, if we look at these two equations, you could argue that if 1 by infinity is equal to 0, that means 2 by infinity is also equal to 0, right? That seems like a very logical statement, because if infinity is so much greater than the number 1, then infinity is also so much greater than the number 2. So it should also approach 0 or be 0 in itself. But if we take that to be true, that just implies that 1 is equal to 2. Huh? 1 is equal to 2, that's just fundamentally wrong. That just breaks everything. But the fact is that with the infinity axis, it does not imply this anymore. And the reason that works is because this infinity that we have in 2 infinity is equal to 0, this infinity is actually larger. We can think of it like this. Think of it like 1 infinity 1 is equal to 0, 2 infinity 2 is equal to 0. In these two cases, we have the equation that infinity 2 is greater than infinity 1. And because these two infinities are not equal, that is why 1 is not equal to 2, because infinity 1 is not equal to infinity 2. And that is the fundamental key that we needed to catch here, that infinities are not equal. And now that we have this value, suddenly, instead of 2 by infinity, we can replace this infinity, rub it off, and we can write 2 infinity is equal to 0. And suddenly, this statement makes so much more sense. The 2's and 2's get cancelled, and you're left with the fundamental equation 1 upon infinity is equal to 0, which we all know is true. Similarly, in our equation 1 by 0 is equal to infinity, we can put the value of 1, we can change it to be 2. Again, arguing that 0 is also much lesser than 2, so this will also be infinity. But again, this won't be infinity, but it'll be 2 infinity, because it's going to be a greater than this infinity. This 2 infinity will be greater. And again, the 2's and 2's get cancelled, and you're left with the fundamental equation 1 by 0 is equal to infinity, and not 1 is equal to 2, because 1 is not actually equal to 2, of course, right? So if you think about it in depth, and if you like really apply your brain, then you'll see that this sort of just snaps everything into place. That like massive paradox about infinity that we have, suddenly it's all gone, our mind is like crystal clear in front of us again. And basically, so that was my entire theory on infinity, and I would like to know what you guys thought about it, and what were your thoughts, and sort of if you could disprove it some way. But I would love to get sort of feedback. This is just me. I've debated it with a couple of people around me, and I don't really see any flaws, but I would love to hear your guys' opinions on it, and whether in general you like these sort of math videos at all. Also, a couple of new formulas that I've derived from this is n, any real number n upon 0 is equal to n infinity, where n is n times infinity, right? This is not divide, okay? This is basically, let me just rub all this. This is basically n into infinity. This is one equation, and the other equation that you can have is that n upon infinity, upon n infinity is equal to 0. N into infinity is equal to 0. So these are basically the two equations that come out when you think of infinity as a sort of a separate plane, a separate number. And when we do think of infinity like this, all of a sudden infinity has so much of a more, a defined place inside our number plane. Like all of a sudden now infinity has a spot, instead of like being here somewhere undefined at the end of the real axis, all of a sudden now it has a place over here. So yeah, let me guys know. I love to do this kind of stuff, huge mathematics guy kind of thing. So let me guys know if you enjoyed, and catch you on the next one.